हेलो प्रिय छात्रगण और YouTube दर्शकों तथा मित्रों, आज का वीडियो मैं डॉक्टर भट्ट एक विशेष घटना पर आधारित है और वह घटना दो पड़ोसियों के बीच की है। पड़ोसी हैं जो कि किसी सोसाइटी के दूसरे फ्लोर पर पी ब्लॉक में रहते हैं और उनका फ्लैट नंबर 7 व 8 है। इनका नाम आप जानना चाहेंगे तो एक का नाम है मिस एन और दूसरा का नाम है मिस्टर ओ। दोनों पड़ोसी हैं, नेबर्स हैं। दोनों में विषमताएं भी हैं, लेकिन संबंध बनाए रखना अनिवार्य है। क्यों? क्योंकि वो दोनों पड़ोसी हैं। मिस्टर ओ बहुत ही सक्रिय हैं। वो सामाजिक रूप से बहुत ज्यादा क्रियाशील हैं और किसी को भी बड़ी आसानी से आकर्षित करके उससे प्रतिक्रियाएं करते हैं, जबकि मिस एन लगभग उदासीन है। लेकिन उनको मिस्टर ओ से सामंजस्य बनाना अनिवार्य हो जाता है। क्यों? क्योंकि वो पड़ोसी हैं और इस तरह से वो दोनों एक प्रोजेक्ट में सम्मिलित हो जाते हैं और उस प्रोजेक्ट के कई प्रोडक्ट्स भी हम लोगों को मिलते हैं। इन प्रोडक्ट्स को उनके अनुसार उनका नाम पर आधारित करना पड़ता है। तो ये प्रोडक्ट्स अब आप शायद अंदाज लगा चुके होंगे, नाइट्रोजन और ऑक्सीजन की क्रिया से बनने वाले हैं और जिनको हम बोलते हैं नाइट्रिक ऑक्साइड्स। और इस तरह से 5-6 प्रोडक्ट्स वो बना देते हैं। 5 या 6 नाइट्रोजन ऑक्साइड्स उत्पाद के रूप में, प्रोडक्ट्स के रूप में हम लोगों को उपलब्ध हैं। और आपको आश्चर्य होगा, इन प्रोडक्ट्स का नाम भी अलग अलग है, होना भी चाहिए। और उसके अनुसार अगर देखा जाए तो उनकी विशेषताएं या गुण भी अलग अलग हैं। और आप नाम जानना चाहेंगे तो जरूर बताऊंगा। ये हैं नाइट्रिक ऑक्साइड, नाइट्रस ऑक्साइड, नाइट्रोजन ट्राई ऑक्साइड, नाइट्रोजन टेट्रा ऑक्साइड, नाइट्रोजन पेंटा ऑक्साइड और नाइट्रोजन पर ऑक्साइड। तो इस तरह से 5 ऑक्साइड्स उत्पाद के रूप में नाइट्रोजन और ऑक्सीजन, जो कि पड़ोसी के रूप में अब हम कह रहे हैं, केवल इसलिए कि वो पी ब्लॉक में हैं और ग्रुप 7 और 8 में हैं। उनका एटॉमिक नंबर नाइट्रोजन 7, ऑक्सीजन 8. Nitrogen is almost inert, but not like noble gases. It has lone pair of electrons also. Therefore, even though it is an inert gas, we find it not very reactive, still it reacts with oxygen to form 5 oxides. And these oxides have different properties. Now let us see what are their properties. In fact, their oxidation number varies from 1 to 5. Nitrous oxide 1, nitric oxide 2, nitrogen trioxide 3, nitrogen tetroxide 4, nitrogen pentoxide 5, and nitrogen dioxide and that is nitrogen peroxide and नाइट्रोजन टेट्राऑक्साइड, ये दोनों अगर आप देखें तो नाइट्रोजन N2O4 और NO2 वो दोनों एक बहुरूपीय हैं. दे अंडरगो डाइमराइजेशन, जिसको कि हम बोलते हैं दो रूप, दो फॉर्म बनाते हैं. अंडर पर्टिकुलर कंडीशंस दे डाइमराइज. नाइट्रोजन पेरोक्साइड NO2 जिसको हम लोग बोलते हैं, इट्स अ गैस, while nitrogen tetraoxide N2O4 सॉलिड. और देखा जाए इनके भौतिक गुण भी, फिजिकल प्रॉपर्टीज भी अलग अलग होती है. कोई गैस है तो कोई सॉलिड है, कोई थर्मोडायनेमिकली स्टेबल है, कोई अनस्टेबल है, कोई पैरामैग्नेटिक है. पैरामैग्नेटिक मतलब उसमें चुंबकीय गुण भी हैं, और इस तरह से विशेषताएं भी प्रत्येक नाइट्रोजन ऑक्साइड्स की अलग अलग हैं. तो और हम आपको आश्चर्य होगा, दो गैसें जिनको कि हम लोग और डॉक्टर्स भी अच्छा यूज करते हैं, एक को कहा जाता है लाफिंग गैस और दूसरी को डॉक्टर्स इस्तेमाल करते हैं जो कोई नाइट्रिक ऑक्साइड है, हिस्टेरिकल और ब्लड प्रेशर को कंट्रोल करने के लिए भी यूज करते हैं. नाइट्रस ऑक्साइड causes sensation. So like that there are different properties. तो लीजिए अब हम इसके बारे में विस्तृत वर्णन करना चाहेंगे, कृपया देखें. Okay, now let us have a quick review of nitrogen oxides. And as you find here, nitrogen has got 5 oxides which are named as N2O nitrous oxide, NO nitric oxide. This NO is very often termed as N2O2 also. Then N2O3 nitrogen trioxide, N2O4 nitrogen tetraoxide, N2O5 nitrogen pentoxide. Okay, the naming is quite simple. It is tri, tetra, penta. Of course, here you have to take care that this is nitrous oxide N2O, and N2O2 are, you can call it as NO, is nitric oxide. So far as oxidation numbers are concerned, the oxidation numbers as calculated, you can very easily calculate, is +1, +2, +3, +4 and +5 respectively. Of course, N2 is also shown here. Nitrogen gas is diatomic and therefore its oxidation number is 0. Now, as mentioned here, these oxides have a typical structure. Of course, we can't say it is very typical. Once we understand it, it becomes very simple also. Now, let us see what is simple or typical there in N2O, dinitrogen monoxide, and this is also named by way of a stock notation as nitrogen 1 oxide. This is known as a stock notation. Of course, the symbol, the formula is N2O. Now, let us have a look on Lewis dot resonance structure. It's like this. It shows a resonance. What happens? It is simply because of the lone pair of electron that these over oxygen atom, that lone pair, these resonating structures appear. It's a colorless, unreactive and neutral gas. not very reactive. And this gas, as is known to us, I have already mentioned, is also known as laughing gas, simply because it causes a sensation uh, in our nerves which makes us feel like a laugh, and therefore we call it as a laughing gas. Hysterical laughter when inhaled in minor doses. Minor doses. Okay, next is gas which is known as N2O2 or NO, we call it. But better, since all the gases are mentioned as N2O, N2O3, N2O4, N2O5, we should call it as N2O2 also. So that brings almost similarity. But since 2 is common in nitrogen and oxygen both, we write it as NO. Now nitric oxide in stock notation, this is also very important. One must learn how to represent these nitric oxide in stock notations. This is nitrogen 2 oxide. Then, so far as the Lewis dot structure is concerned, this also has a resonating structure like this. And then it is again a neutral gas, colorless. But what is more important is that because of the lone pair of electrons present here and the 3 electrons shown together here, it is paramagnetic. Paramagnetic. Thermodynamically, it is stable and is quite reactive. Oxidation number we have already calculated, and we know that it is the oxidation state of nitrogen is 2. The gas again is very reactive, harmful. Biologically, it acts as a neurotransmitter and helps in controlling blood pressure by relaxing blood vessels and prevents us from bacterial infections when taken in limited doses. Then the third gas, as we know, is N2O3, that is nitrogen trioxide, and in stock notation it is written like this. We call it as dinitrogen trioxide better. Simply you say nitric or nitrogen trioxide, that makes also to understand that it is N2O3. But better we write it as dinitrogen trioxide or nitrogen 3 oxide in stock notations. Then this also has got a resonating structure. So we find that all the gases of nitrogen and oxides, all 5 gases, have resonating structures simply because the lone pair of electrons here and a double bond present. So it's a unstable in gaseous phase. When it is in the gaseous state, it doesn't exist. Then, of course, in solid state, it is pale blue solid. Then, as a acidic character, we know that the oxides can be neutral, basic, or acidic, depending upon what type of solution they form when dissolved in water. So it forms an acidic solution. Oxidation state is +3. Now, next gas, what we can make out is nitrogen tetraoxide, represented like this, and resonating structure. Again, here you can say it is 2NO2 combined together and have a resonating structure, nitrogen peroxide. This N2O4 is also known as nitrogen peroxide. Of course, we are coming to it. We shall discuss about what is the basic difference between N2O4 and NO2. Again, it's a colorless solid or liquid, acidic in character, oxidation number is +4, and that's what I was just pointing out, that it occurs at equilibrium state with what is known as nitrogen peroxide, which is a gas, and N2O4 is a liquid. So this is known as dimerization. Two forms of the same compound nitrogen tetroxide and nitrogen peroxide. Now, let us see what is nitrogen peroxide. Just now we have learned that it is because of the nitro dimerization that there is a gas which is known as nitrogen peroxide. It is a brown gas. Again, there is a resonating structure like this. The lone pair of electrons are here, and it is because of the odd number of one electron on nitrogen atom that it shows resonance, as represented here, termed as nitrogen dioxide, or we call it nitrogen 4 oxide, and very commonly it is also known as nitrogen peroxide. Then, of course, a brown gas. I suppose when you carry out experiments, qualitative analysis in your labs, you find a brown gas for detection of NO2, NO3, nitrate. Okay. When the mixture or the compound is mixed with concentrated sulfuric acid, you get a brown gas, and that brown gas is nothing but nitrogen peroxide. So it confirms the presence of nitrate. But anyway, nitrogen peroxide is a brown gas. Again, acidic in character, and it shows dimerization, which we have just discussed, that N2O4 is one form of the same compound and NO2 is another form of the same compound. They are in equilibrium state. Now, next we discuss about nitrogen pentoxide. Nitrogen pentoxide is N2O5, and notation is nitrogen 5 oxide, stock notation. And look here, the structure is very simple here. Lewis dot structure. It is 2 NO2, two different NO2 compounds, nitrogen peroxide, joined together by an oxygen atom. So that's simply a representation. How to write it? If you are required to draw the structure of nitrogen pentoxide, just write the structure of NO2 on both the sides and link them with oxygen. The resonating structure you have to take care. Then here it is a colorless solid. Oxidation number 5 है, and gas is unstable solid. It state it exists as NO2 plus NO3 minus. It is an unstable solid. Okay, we stop here, and we should be back with some more details about certain other topic soon. Thank you very much. Please don't forget to hit the subscribe button so that we feel encouraged. Thank you.